Okay, we're back live. With that, let's go through the project. With the goal of today is to really individually go through the development and maybe also discuss the strategies of how you want to present your work tomorrow with our guest reviewers. And maybe, as we had now 2 times already, the groups present in starting with group 1. Let's reverse order for today and start with group 10, if you guys are ready.
Yes, I'm ready.
Great.
Let me share my screen. Actually, I don't find my Rhino. Please let me close some of the unnecessary files. Do you see my screen?
Yep.
Okay. As your recommendation from yesterday, in order to solve the previous problems, I analyzed several models. Let me hide these beams. This is our boundary, which I modified manually in these cave regions. I don't think I have the previous one to see the difference. I'm sorry. Okay, this one, this was our previous. I modified it in these parts, and I carried out 2 simulations, one with these 6 columns here, and one other with 12 columns, which I added some columns in these parts. And for the first simulation, this is the optimized topology optimized mesh which I obtained, and these are the curves which I still had some very small in these parts, but these were not out of boundary like yesterday. So I manually deleted these very small curves here, like here, in a better organization of beams. And with this modified curves, I obtained these beams, as you can see here. They are mostly organized, and there are not any chaotic or turbulent arrangement of elements like yesterday. And this is the one which I carried out with 12 columns. And this is the mesh that I obtained. As you can see, as I have here some separate distribution of materials in some parts. According to their Hua's recommendation, I decreased the load for the mesh, but still didn't obtain a continuous mesh. But I continued, and these are the curves um, which are not at all out of bounds for robotic, and these are the beams that I obtained. Um, there was there were some problems in the arrangement of beams, for example, in let's see. For example, in some parts like here, I only have beams which are placed on top of each other in one direction, and there is no other elements for connecting each layer by the next layer. And I don't know if it's some maybe we don't have a have efficient structural behavior in these parts, but I don't know how to solve this. And this is about our form, and I will later go to the robotic simulation. If you have any comments.
So this looks already pretty good. Dahua, you want to explain what's going on?
I think another group have already talked about this problem yesterday. I think it's just the way the program we provided works. So when now you can see there you have a very long curve, and then it was subdivided to fit more element there. But if the gap between the small elements is too small, if the gap is too small to fit in a connection in another direction, then there won't be any. That's just how it works. So my suggestion may be, if you want to have the results looks totally totally fine without any problem like this, you may need to manually adjust the curve you input. Like, oh, sorry.
You mean these parts, for example?
Yeah, maybe now you have like two segments, like one very long one and a very small one. Maybe you need to adjust the input curve as maybe you can cut this in the middle. You have three segments at the input. You can try different options. It may work differently.
Okay.
Yeah. But this part for the discontinuously, I'm not sure.
The all parts are fine. I only have some bugs. For example, here. I have. This is not continuous. I didn't understood why myself.
Did you join the? I mean, sorry. Did this segment and this segment actually touch at this point? Did they meet?
I didn't join them. I just.
You don't have to join them, but they have to meet at the same point. If not,
you mean their endpoints? in
The
one
end should
position.
you should check this, but if there's no problem here, then actually I'm not sure why this happened. You can check this.
Yes, sure, I will check it. But I think the overall pattern and the overall arrangement of elements are quite good, and I will try to handle these parts with one direction beams. So should I go to the robotic simulation? And about the 6 columns and 12 columns, which one do you think I should go on working with?
So this pattern, this beam layout seems not so satisfying as the previous ones. And maybe you got a lot of small segments and a lot of joints that contain more than three segments. That may be hard to fit the timber element in, so it will look a little messy.
Okay, so I will continue in this form, and let me show my screen again. Maybe I first play this video. I first of all, I should precisely on the robotic simulation. I still have some questions and problems, but let me show my still about the video. Do you see my rhino right now?
No.
No?
Not oh.
What about now?
No, not for me.
Wait a minute. Yes, yes, you can see your screen. Dear Farzan, you just have to wait a minute. Wait a little.
Is it visible
yes,
right now?
you can see your. Yes, it's okay.
Yes.
So I decided to divide the whole pattern into 6 smaller sections. And for each section, I think I need to subdivide it again because I don't have the robot can't place all of them due to its reach. And the problem which I have in this part was that the beams are not placed based on their z direction. I mean, if we consider these 2 layers as 2 branches in Grasshopper, first, the first layer with a lower z direction needs to, and after that, the second layer should be placed. But what I got here is that these elements are not placed based on their branches. And for example, when I run the simulation, it sometimes firstly places the second branch or the third branch, and after that comes to the first branch. I think that would be a problem. I checked as I'm not wrong. Here in the definition, we are in this part. We're sorting the planes along curve here in order to have a proper arrangement of elements. But when I run it just with it's not. It doesn't work fine. If I show you again this video. Just to not lose the time, I will. For example, do you see my game player right now?
Not yet.
Okay. For example, for this little section, the last element that the robot is going to place, as you can see here, is this element, which is
Your
in
video here.
which have a lower z coordinate. And
Fasani?
yes.
I think the video is playing on the other screen. Maybe you only see your Explorer.
Yeah, we cannot see your video.
So let me share it again. The cam player is actually not in my list, so maybe I show it. Do you have my Rhino screen right now?
Yes.
Yes.
Okay, I was just saying it's a bit heavy. I'm afraid maybe it stopped working, but when the robot wants to place these parts, for example, after placing every part, it comes to this part for the last element, as it has lower z coordinates. For example, the robot first placed this part, and if I when I tried with multiple layers, for example, first goes to the third or fourth layer, and after that comes to the lower layers. I think there might be something wrong in this part when I'm sorting the planes here, but I couldn't solve it myself.
Yeah, I actually did a lot of thought before this part, and this thought is not for the sequence of the elements. This is just for the nailing, nail the first one, and the two nail points, to sort the two nail points on one element. So I may need to check somewhere before, but I'm not sure. Maybe some of you may also encounter this problem. Maybe I will test more, because when I tested on my computer, I didn't see any problem. Maybe it will be best if you can show me the video.
Unfortunately, I cannot.
Or you can post that in the Google Drive folder. I will check.
Yes, sure. I will put this in. And one more question, if I'm not out of time. As I understood, the elements after the robot picks the from here, if they have intersection with their bottom layer, the robots will go here to apply the glue, and after that place it in this position. But as I tried several times for several sections, all the elements are the robots.
Yeah, the robots will always go to the glue station.
Yes, yes.
Yes.
I think for the first layer, because we don't have any intersection with the bottom layer, we should not have this. I don't know if it's a problem with my work or just the definition.
No. Yes, you're right. And the program just works as you said. It always went through all the packing, gluing process, and then went to
but I think we could change it if it's possible.
Actually, it's possible, but I think it would be very complicated.
I understand.
Yeah.
I have a question
just,
about.
You have to.
After.
Sorry, go first.
While she's working, I'm trying to load the camp layer. So if you happen to see it, let me know.
No.
Okay.
Can I ask my question now?
Yes.
When I was working on my robot definition, let me share my screen, please. You can see my screen. When I want to run this component, it's sometimes turning to orange.
Sorry, I didn't see anything yet.
Let me. Let me try again, please. I don't know what's happened. I don't know why I can't share my screen. Honey, if you have any question, you can ask again. I try it later.
Okay, do you hear me?
Yes.
Okay, let me share my screen.
Yes, yes.
Okay, I had a question about our work. This is just my laptop problem, I think. In this case, I don't know why my C# code is in red. I do everything right, and
what it says in
this is the error.
I think this error. mostly happen when you don't have intersect between your plan and the mesh.
But the other part of it is right. I don't know what is the problem.
Can you check the input, check the mesh and the plan if they are intersected? I mean the inputs. You can directly check the inputs from the C#. Yeah.
Here.
Yeah.
This is my mesh, and I don't know. This is just my problem. For example, this code is working on my friend's Farzana, for example, but it's not working in my laptop. I don't know what is the reason. Because of that, I asked you.
Then that's weird.
Yeah, I don't know why and what is the problem. So I try to ask. It said that this line 80, I don't know, I clicked on the code and
Yeah, I think mostly it's yeah. There's no intersect polylines. It most happens because there's no intersection between the plan and the mesh.
I think her columns position may be wrong.
Columns are exactly in the surface. I tried it.
No,
Several
you just need to check the first two input of this component if they are intersected.
Honey, if it's the code that I sent for you, it shouldn't have a problem with the position of the columns. But if it's something else, you should check your mesh and columns position, I think.
I tried several times, but I don't know what is the problem. I have to check.
I uploaded my video, by the way, on the Google. It's there, Hua, if you if you want to check the video, you can go on the Google Drive, day 4, group 10. I uploaded 2 videos there. One of the videos is for this project, and one other is from one of my previous projects, which I did in KUKA PRC, and I just uploaded to show that I wanted to have the first layer of elements without applying the. But in the first video, you will see that every them are going for the blue.
I only see one video there. And
maybe the second one has not uploaded completely yet.
Yeah, and it's your question problem that it's the sequence of the fabrication. It's not right. It's but actually I can see very clearly on in this video.
The last the video, I zoomed the screen right into the beams. You move forward the video. For example, I guess you can see the last element which is placed in the first layer of the beams.
Yeah. Yeah, that's weird.
And the second video is uploaded, I think. And the second video is about the first layer, which I didn't want to be applied with the glue.
Yeah, I think I got your question, and maybe I need to check the files I shared. And
Yeah.
I can give you explanation now. Yeah, I will check this later. Yeah, and check the problem later.
Thank you.
Can I try again my share screen?
Okay, thank you.
Okay, thank you. It have problem. I don't know why. Okay. I can ask my question later. Okay. Thank you.
Okay. Let's figure that out in the chat or in via email, maybe, right?
Thank you.
Yes. Yes.
And let's go to the next one.
Thank
Thank you all. It's really exciting. And I guess for tomorrow, maybe make sure that you are properly prepared to do a smooth presentation. Each team is gonna have 5 minutes max. Otherwise, we're gonna not get to having a conversation with the guests, right? So two things are important. So you have your presentation ready in, let's say, a PowerPoint or a Google Slides or whatever. Yeah? The goal is gonna be that you share your screen and you present from your computer, right? But as a backup, if the screen sharing doesn't work and or you have other problems that might happen with internet connection and so forth, then you should also have your full presentation uploaded on the Google Drive, right? So that then either Hua or me can open it and still present. Yeah?
Sure.
Okay,
Thank you.
great.
Thanks.
Sure. Thank you.
Now group 9 is Zhang and Yixian.
Hello. Are you here in the meeting? You will get
Yishian is here.
and get the message in the chat window.
Ah.
Let's move to group 9. Go group 8.
All right.
Yeah, group 8. Let me share my screen. So for yesterday's progress, first we evaluated the whole space, whether the robotic can move around, and then it's all reachable, luckily. So the space height is 3.2. I think is in the good range for the robotic arm. And then we further more to develop the. This is like a close-up. Like first we test like one small parts, and like one by one, and then we just like scale up to the test all the floor from level 1 to level 2. We think like overall is okay. This is for the robotic fabrication part. The simulation works for us. And then for the second part is the ISO curve over the magnetic field pattern. We keep on develop that for the both floors. We think it's okay. So the total, now we give them the floor slab like 100 mil. And then for the beam is 100 to 150. And then this is like an overall. Yeah, this is the progress for yesterday. That's it.
Okay. I think this is a pretty cool development. I don't understand. So the isocurve beams, are they already planned, or is this basically an extrusion at the current moment?
No, we didn't do like the structural optimizations. This is just like an extrusion from the curve.
Yeah.
And then for the
you could still plan the beams, right? I mean the sticks, or not? Did you try that?
What mean the sticks? You mean using the curve? You're using the curve and then run the simulations using the sticks, right?
Yeah. I don't mean the topology simulation, but the generation of the sticks, of the timber pieces.
Yes, it's also possible. I think then we need to like maybe it's still too dense for the sticks.
Yeah, that's why I'm asking.
Maybe you can try some other way to generate the beams, not in the way that we provide. And I think it's also quite interesting.
Which one?
I mean, in this with this ISO curves, if you use the ISO curves to generate beams with the tools we provide, I think you may get a lot of problem because it's too dense and there's somewhere that the segment is too small actually, and maybe you can also think about how to generate beams with this pattern yourself, and that I think that would also be a interesting exploration.
Yeah, we could try. Yeah, we also can try maybe using the sticks to try if it's adaptable to this kind of pattern.
Yeah, you could try.
Mm.
Good.
Okay.
I think for you guys, you already have a couple of nice illustrations, but same applies to you. So just make sure that you have your presentation ready for tomorrow, right? That combines all the material that you want to show in a concise manner. I guess don't forget to explain the metaball strategy, to explain also the spatial boundary concept, right? And then I guess it would be interesting in your case to kind of compare the topology optimized structure with the isogrid or magnetic field, right?
Yeah, I
So
think for tomorrow's
I would keep both of them, and maybe you can have them somehow in a comparative manner presented, and then it's maybe a nice discussion on what these kind of patterns could be.
Yeah, okay. And then for the presentation, is like each team 5 minutes to 10 minutes, or
Just the family.
No. 5 minutes max.
5 minutes.
Max.
Okay,
Maximum. And after, if you go beyond 5 minutes, we need to stop your presentation. Unfortunately.
You will just
We're quite flexible now today, but tomorrow, as it's gonna involve Professor Ruan and the guests, we need to have a bit of an organized fashion so that we actually give every group the chance also to present their work. So we need to be very strict on that. It's plan your presentation maybe on 3 minutes, and then maybe you have 1 minute calculated for eventual problems with the slides or whatever.
Okay.
Good. Great.
Okay, thank you.
Then group 7, no? Hans and Ben. Ben, we can see your screen, but I can't.
Yeah, I was just trying to find the unmute button.
Ah, yeah, great.
Okay, cool. So we've fleshed out our design a little bit more. So the basic alignment that we did the other day, we've retained, but we've kind of moved to something that uses more like larger sections so that we can use like off-the-shelf LVL sections instead of like small little timber pieces. And we've designed the joints a little bit so we take advantage of robotic construction, connecting everything from below. So the joints that we're thinking are lots of dowel connections where the members basically slot in, we place the dowel, and then we glue the bottom flanges of the beams from below so the dowels become hidden. So that kind of takes advantage of if you're building the beam up on site, you can do something like that. And it kind of helps create like a integrated two-way grid through the structure. I think a lot of current timber tends to be something where you have like either 2 layers of beams that are stacked on top of each other to make something like a continuous two-way grid, or it tends to be something where you've got like primaries in one direction and then simply supported beams in the other direction, which are just a little bit less efficient. So for simply supported connections, which we have out near the cantilevers, for these we slot the secondary beam into the web of the primary. And so the pin is mostly just to keep the secondary beam from pulling out. So taking kind of axial load there. And then this interface at the bottom is to transfer like the vertical shear load. In cases at the base of the cantilevers where you got a moment connection, we continue this where we continue the bottom flange of the secondary beam all the way through, and then use a few different like grouted pins or epoxy pins that are basically kind of similar to like a bolted design or a bolted connection, which can be efficient with timber. And then the cases where we've got beams running continuously through, the concept is very similar, but the two beams just kind of meet in, become doweled, and then the bottom flange gets glued on from the bottom. And then we were looking at some of the dimensions for the CLT. So this one span over here is a little bit long, but all the others could basically be constructed by cutting out a long rectangle and then slicing it with a diagonal, and that would basically fit within like the standard like 3.2 meter CLT bay width. And so you can kind of make a wedge out of a square and use all your materials efficiently. But then we wanted to make it all continuous, so we were thinking maybe we could take the top ply of the CLT and then cut it out at like a horizontal cut or an angled cut, and then glue it in on site. To kind of be consistent with all the other glued joints. So right now our grasshopper definition has the general like cuts and layouts done. We're adding in the cuts for the little dowels and then the like robotic assembly. But the basic bit is there. So that's what we have.
All right. Super interesting. I think you're bringing a lot of new things into the conversation, which I guess is very positive. At the same time, I'd urge you to then also bring forward the integrated concept of how the robotic fabrication would work, right?
Yeah.
I guess especially with the dowel, I'm not sure actually with the dowel per se. I'm not sure if it's also strong enough, right? I guess if you would glue that that beam inside the pocket by having those beams kind of sequentially glued together would actually be quite a lot stronger probably. And
yeah,
and you would know how to fabricate it. But I mean, if you have a concept for the fabrication, then I'm also happy.
Yeah, so like glue joints definitely are stronger and stiffer, but bolted joints are also reasonably strong. And I reckon that we could probably develop the required strengths or like the strengths required. But yeah, I mean, using more glue joints would be fine too.
I mean, it's up to you. I guess gluing the whole thing would have the advantage that I guess for tomorrow, then for everyone is also clear how it's gonna be assembled, right, by the robot. With the bolt, I'm just also not sure how you would want to robotically fabricate it, right? Because the bolting is normally something that that's really designed for a human to do. But yeah, as I said, if you have a concept for that, then...
Yeah, I mean, these aren't bolts. I was saying bolted because the way that it developed its strength is similar. Yeah, but it's basically dowels. So maybe we don't have like a specific like clamp on our particular robot, but I mean, if you can pick up timber, you can also have a clamp that picks up a dowel. So I think it would be feasible with a robot, if not necessarily
so
ours.
it would be kind of like a loose fit dowel. You just push in, because like I guess most of the dowels dowel projects that I know about are actually dried beach dowels, right? That then you kind of hammer in and then after they kind of soak in the humidity from the surrounding wood, they also expand and then really sit in the structure like very tight fit. That's I don't know if you know the projects, but that's mostly like a human robot collaboration, right? So you kind of assemble the pieces, then you have the robot drill the hole, and then you have the person, the craftsman, coming in with a dowel and with a hammer, and you put the dowel in.
Yeah, I got it. So you're talking about the hammering action when possible with the robot.
I guess, yeah.
I understand now.
Not to say that it's impossible to do with a robot, right? But it's a weird problem that is like very easy for a human and actually not so easy
and
probably
very difficult for a robot.
For a robot, yeah. You need to find the hole, right? To kind of fiddle the thing in. Yeah.
Okay.
I don't know, Hua, what do you think?
Yeah, I'm also not very clear about the fabrication process. I mean, sure, this project just bring a lot of interesting aspects for this structure system. But for our workshop, we are proposing this fabrication. What we are proposing is all based on this kind of fabrication methods that we are developing. Actually, we also encourage you to think about your own fabrication strategies, but I would recommend to maybe stick to the fabrication method we are available now.
You're just referring to using a glue joint.
Yeah, I guess with kind of like the glass being sequentially assembled. I mean, you had this pretty amazing study of how you could actually have more kind of robust joint, right? Overlap. You showed it on day 4, I guess, or you remember? The things kind of coming sequentially on top of each other.
Yeah, so I guess at this particular span, when I started looking at it a little bit deeper, like the amount of glue that you would actually use to do that would like triple versus what would really be like required. And so maybe if you were to build it out of like the small timber beams, like, yeah, that would be like one way to do it. But if you were to look at how to do this like in practice, I feel like using kind of like larger beams, maybe they would be larger than what the robot for this workshop can handle. But if you were using this as like a case study of what could be done in practice, you'd probably want to use like LVL sections that are kind of available. So those, at least from the suppliers that I've seen, they kind of have like some minimum dimensions.
Would you have the LVL layer standing or flat?
Yeah, so each of these pieces would be like LVL beam, and they would have like minimum of like 3 plies. So these would be like 45 mm thick as like a minimum. And so like to chop that down into smaller pieces and then re-glue on site.
Wait. That was are you talking about cross-laminated timber or LVL?
Oh, sorry, for LVL for these beams.
3 plies in LVL would be like 6 millimeters or something.
Yeah, but like this section would be like a 1 LVL beam section. So like you could chop the beam into smaller pieces and then re-glue it back up on site. Yeah. But that would be adding a lot of glue to the project. And unless there was like a lifting constraint on the robot, it would just make it more expensive, more difficult, take longer to assemble on site.
I hear you. I think it's valid argument, but I also think it kind of bites itself in the tail, because LVL per definition already has like kind of is the product with the most glue inside already. But as each layer is like only 2 or 3 millimeters thick, and then there's quite a substantial amount of glue inside. Whereas if you have a glue lump beam, right, which essentially, I guess, you would fall into if you're kind of assembling piece by piece with just with timber beams, right? Then you only have a glue layer every couple of centimeters, right? Which is then substantially less glue. Yeah. I don't know. I mean, I don't want to, push too much in different directions. I mean, it's also totally fine if you want to kind of propose a different way of going about it. I think it's just our job to get in, to make you aware that maybe for the audience, it's not gonna be quite clear how this would be automated and how it would be falling into the whole other framework. But I think that's also, if you want to go further with this kind of approach, then that would also be maybe an interesting discussion point or something.
So these could also potentially be like 2 or 3 layers that are then like glued together on site. Like, yeah, that doesn't fundamentally change like anything here. Like,
exactly,
it's totally,
yeah. I think that would be like a very small adaptation, and would make the whole concept very much more kind of aligned. You wouldn't need to explain too many other things, right? I think, yeah, I would definitely feel that would be quite valid. And I guess I would also show your studies from last time we saw you. Because I thought those
optimization stuff. Yeah.
No, I mean, yes, of course, also that, but also the the topology optimization was pretty cool. Definitely. But what I was talking about was the study on how you would actually achieve this kind of overlapping points with the hollow section in the middle, I think. I'm trying to find it in the Google Drive. I'm not sure.
This?
Oh yeah, exactly. I think this is super clever. It's a super clever way of addressing the issues at hand, right? I remember the main point was to close it off, right? To have like less fire load on the structure.
Yeah. So basically, like this and this are the exact same, except for in this case, the different layers are just one timber piece.
Yeah.
Instead of being split.
Yeah.
But it's still making a box, still slotting through. So all those aspects are the same.
Yeah. So I guess that would be cool to kind of merge, right? I guess if you want to what your project could really contribute to the conversation tomorrow is this kind of discussion about how this would kind of evolve in a very concrete project, right? So you have a very specific situation where you say, okay, that's actually a building existing building, and there is a clear challenge at hand that needs a solution, right? And at the same time, it offers an idea of how these kind of, even though very intricate structures could beam arrangements could also become more closed off, right? Very much resembling a glulam beam, but because it's kind of assembled on site, has the potential also to include kind of a branching, right, of the glulam beams, which typically is possible to do, but no one would be able to transport it efficiently, right? So I think that would be a really interesting contribution.
Yeah, you'd never be able to do this joint unless you use mechanical connectors. The size would be too big, and assembling this on site efficiently wouldn't be possible if this was already connected together. Yeah, so there's definitely advantages for this type of structure for robotic construction.
Okay.
Cool.
I guess for tomorrow, for you, I'm not. I don't know. Like, I guess the architectural stratosphere is very much used to telling a story and to explaining the different parts that we feel are innovative, right?
Wait, sorry, could you repeat that? What did you mean?
I just
architectural stratosphere?
Let me maybe start again. The point that I tried to make is that specifically in your project, I think there's a lot of very interesting ideas, right? That I think it's very relevant for tomorrow to think about how to bring them into the presentation and make them clear kind of from start on. Specifically in the broader context of the workshop, right? So I guess there's gonna be a couple of other projects for your presentation, right? And then I guess it would be unfortunate if then most of the conversation is around whether or not that's assemblable by robots, right? But I would really feel a more interesting conversation, especially with the guys from practice, from the offices, would be probably around, okay, how could this really be applied in a project, right? What kind of fire safety measures might be interesting, right? And I think this would be quite a fruitful discussion.
So in terms of the 4 different joints, like these where the member is just being lifted up and applied from the bottom, they're very easy to apply like a glue line. Same with those. For this one, where you have like a member being fit into a hole that's like pretty similar to its size, I wonder, like, if you apply like glue and then you shove it into a constrained area, I feel like the glue wouldn't really be, it would just be like pushed, and it wouldn't really actually coat the surface.
There is new glues where you can do that, right? That are basically gap filling, but they're also basically the most toxic, and obviously also you need more glue if you need to fill up something, right? So I guess what I would propose here is just to
do the layers.
Do the layers, and then it's pretty straightforward how this comes together. And I think in your initial sketch, I think one of the main points that I thought was very, very exciting actually was that this piece here, right, was not only connecting to this guy, but also going into the into the second one, right? So kind of tying both sides together, which I guess is like very, very much beneficial.
Yeah.
Okay. Excited what I'm
Cool.
excited what comes out of it. Did you play around with the robotic simulation? Do you want to show something like that tomorrow, or?
We'll show a brief bit on the robotic simulation for
Okay.
construction,
Okay.
if we can get everything sorted on that. But
all right.
At the very least, we'll have this bit.
Okay, cool.
But hopefully the robotic bit as well.
Yeah.
Yeah.
Good. Last comment. I guess I really like the visualization style. I think that's pretty clear.
That is all Franz.
Okay. Well, good. All right.
All right.
Then
yeah, nice.
see you tomorrow. If anything is comes up, just text us or write us a mail.
Sounds good.
All right.
Oops.
Hello.
Hello.
Firstly, I want to introduce the generation of the roof form. As you know, we want to design a building that can be used to various adaptation, and we hope it can be used. It can be applied to it can be applied to community. And so we finally decide to use the dictation unit like this. 3 circles. They are the 3 functions of the detection, and then we arrange the 5 units like this around the circle. And of course, it can be arranged anyway around just according to the set condition. And finally, the roof form was generated according to the layout of the units. And then from yesterday to the day, we finished the generation of structure and beam, and these are the pictures of them. This is the whole model of our structure. So do you think? So do you have any suggestions, or do we have? Is it okay?
Can you go up to the first slide? Can you briefly explain how those units work together? So the detection happens in the big unit, and then there's 2 small units behind, right? And is there like a functional principles for this constellation of spaces, or is that mostly maybe an assumption, or? You know what I mean?
Yeah. We actually we didn't take it into consideration. If we go deep to the function and the others, it's too difficult for us.
Yeah. I think no one expects that you go into the medical details of how this should work exactly, but I was just wondering if there is a specific reason that you thought that one unit is composed out of these three kind of rooms. But I guess we can also just assume that that makes sense, right? That this is a spatial layout that might be necessary, right? And then I think it's already pretty interesting to see how you could arrange this kind of units. Right? In terms of the design, I guess what I would maybe try to do is to actually have a bit more of a, I think in this design up here, right, the slab has actually this kind of cavity in here, which is not anymore here, right? So I guess if it would go inside here again, then the whole thing would be a bit lighter, I guess. And what I also didn't understand is where is your columns, right? Because right now it's I don't know, this is definitely not the right place for a column, right? Because it's in the middle of the room. So maybe it should be here, 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 or I don't know. Right, so I guess that should also be a bit discussed. Or can you show us where the columns are in your current proposal?
Do you mean this?
Next.
Where's the rooms here?
Maybe on the plan. Go to practice slide. 往前翻几到平面，对。Where's the columns on
column?
It seems that you post the columns like here.
Yeah, we put it
in the middle.
Yeah. Yeah. No, here. Here.
Okay.
Here.
Yeah. So I think I agree with Jack that you need to think about this. Why you have this 3 circles and 1 dominant one and 2 small one? What's the function of them in your very clear defined function of the whole pavilion? You want to use it for test or for the medical testing. So why do you have this kind of function? Is it some which is the room and the entrance exists, or do you have a sequence of the people walking in or walk out or something like that? You need to think about that, I think. And also, I think if you avoid the columns in the main area, I think that's okay.
Okay. Thank you. Do you have
Yeah, I think you are actually making progress. And if you go to the next, you have already generated the beams, but I think the proportion of the columns, slab, and the beam is not that preferable. If you could you move to your renders? Hello.
Mm-hmm.
Mm,
Move to render.
yeah.
What do you mean?
放到效果图那边。
Huh?
The next, yeah. I think that you have such a thick, the thickness of the slab, and you have very, very strong columns.
Yeah, I get it. Oh, I know.
And the beams looks very small compared to the slab and column.
Okay, we will check it. We will check the parameter about it.
Maybe we move on to group 5.
Yep.
Shall I start or
Yep.
you two want to start? All right. So we somehow adjust our outline, and now the column are positioned on the offset outline, and this are the outcome of the simulation generation, and these are in render views, and want to share. Want to share with you the simulation part. Are you?
Hello?
Yeah.
Yeah, here we just try to simulate the track of the mobile platform and see how it'll be avoiding the columns and try to find all the roof areas construction. And this is kind of like a very diagrammatic way to analyze where will be where the track will be and the working areas of the robot arm. This one should be a GIF.
No.
That's fine. We just have like a teaser of like this robotic simulation and then just assembling a few of the beams.
Yeah, that's it.
Yeah. So what we progressed from yesterday is we use the dimension of the robot as another parameters to fix our column position and location. And our only concern might be because we somehow exaggerate the gap between the columns to have rational beams. So right now, if we only have the columns, it may not provide us with this kind of feeling of social distancing. So we were thinking about probably add glass as a facade for some area, but we don't know if that's possible.
From my side, it's totally possible. I think that's what we talked about yesterday, no? That it would be actually quite interesting to have a facade integrated within this. I think now that you're moving your robot kind of in this snaky lines, it's actually also quite fun. Then obviously it's pretty cool to see how the sequence of this kind of reposition maneuvers then is able to kind of cater the whole slab surface, right? So I think that's cool. What I didn't understand yet, and maybe that's just because you didn't show it, but I didn't really understand like the architectural space at the current moment, right? I think we were flipping through the images very fast, and I didn't really understand. So what's the concept of your space? Is that like a pavilion in the greens, or is it is it a I don't know, a rooftop, or what's the concept right now?
I think this is supposed to be a pavilion in an open space, like a park or a playground.
Mm-hmm.
Yeah, and I think we try to integrate social distancing as like a design guideline at the moment to create some like spatial partitions for the public space for people that still be able to enjoy outdoors during this time.
Okay, so that means that the lines that we see here would be also kind of closed off, right? So that would be a facade element, I guess. And then you create a landscape of these kind of cavities where people can kind of inhabit the space, being protected from other people. That kind of what you're saying? You're muted, I think.
Yeah, I think it's possible to add some glass panels as the partitions.
These ones here, right?
Yeah.
This one.
Like on the edge of the pavilions.
Yeah. So I think that would be really cool. And is a nice, I guess, a nice concept that is kind of timely, right, at the moment. I guess I would try to make each of those panels kind of inhabitable, though, right? So I think here this kind of area is pretty clear what it is, right? Also here, but then here I'm not sure what I would do here, right? So how would I inhabit the space here? So I guess there is a huge potential in your project in terms of its spatial exploration, right? And I would ask you guys to really maybe polish that aspect a bit more and really show the qualities of the space. I think your perspectives at the moment are a bit unfortunate. If you can open them again.
Maybe we need to repeat.
Can you open the perspectives?
Okay.
So,
do you have troubles with the height of the beams in the program we provide? It seems you have all the beams the same height.
Not really. Take a look at here. It's shear levels. Here more.
But it looks that most of the beams are the height are the same.
Is it possible to remap the density parameters in the script, and then so that we can like have a more contrast of the layering of the beams?
Yeah, I think that would be great, actually. Jahua, maybe we should have a session afterwards with Group 5 to go through the scripts.
Yeah, sure.
Do you think?
Okay.
What I wanted to comment before is that I guess just the way that the perspective is taken with this like very wide angle lens, I feel it's a bit I mean the slab basically looks very massive, right? Where in the floor plan diagrams it's really seems like this very light-hearted undulating slab, right? Then in your perspectives it's really like, okay, something coming on top, right? Maybe that's just like a question of how you visualize your project, but I think that there is a good potential of
yeah, we
making...
just want to show more details about the roof, but
yeah,
not...
I think you also showed like very nice perspectives the other days. So I think yeah, just make sure that you don't undercut yourself, I guess.
Okay.
And let's move on.
Yep.
Can you hear me?
Yeah.
Okay. Our design is still the separate pavilion shown yesterday. Compared to yesterday's scheme, I optimized the columns. I optimized the columns so that and the beams to make them more rational, and also designed several chairs to make it to form the atmosphere around the pavilion. And you can see from these pictures I took before. These chairs are designed by using the same robot to build inside or offsite, and they are built by overlapping wood by another, overlapping the wood blocks and generated by the grasshopper. I can put some curves on the floor plan and then modify the setting to generate it. But I think there are many things I need to be modified to this algorithm for now. Some operations are made manually in the Rhino, like the outlines of this I haven't generated right now. But I'm not familiar with the batteries I want, so it wastes much of my time. To building the logic, it can be modified too. So if I have more times, I will keep optimizing it, but maybe not for tomorrow. And one more thing is, okay. One more thing is that yesterday Zhiying was supposed to introduce her idea, but due to the connection issue, she let me introduce it for her. In order to enhance the virtual effect of the pavilion, we can build an additional layer of wood beams, like here. Beams between two layers of the acrylic board as the architectural surface on the roof, and they are generated by the popular geometry. The pattern is determined by a curvilinear formation system in which tentacle curves grow from the edges and repel each other to form the final organic form. And after that is let me see, the fabrication part. You don't move now. Maybe. Is that a picture or a video in your screen?
It's a picture.
Sorry. Maybe this works. Like that. This. Okay. This. I think arrange the beams on the ground may be more easy and also more practical for us, because when the roof is hung up, and it has started deformation and makes it more hard to control the accuracy. So we can place the platform on the ground, and we can place the platform around the roof and also in the center of these openings, and so that we can reach at every corners of this roof. And after assembled all the beams on the ground, the roof can be flipped by the cranes and placed on the top of these columns. That's all.
Okay. Really cool project. I really like how this is, I think, in a stage that is really advanced in terms of its design, right? I think it's at a stage where quite easily you could imagine a client come and say, yeah, let's do it, right? So that's cool. I think also in terms of your visualization style, there's a couple of things that can be definitely be further advanced, right? I guess in the clay renders, the beams are hardly visible, right?
Okay.
I also would put a bit of more emphasis maybe on the trees, and just
It
make
will
sure
be a
that
rendering tomorrow. Yeah.
and just make sure that they don't collide with the slab. Right from the top views, it seems that they kind of go into the slab. I'm not sure. Yeah, I think, I don't know. Maybe it's just a visualization thing. The S curve I didn't fully understand, but I guess if correct me if I'm wrong. So this is an additional kind of sandwiched layer to hold the panels together. Is that correct?
Yeah. In our imagination, the roof will be a kind of ugly board, and there is another decoration part layer of this these S curves, and then there is another ugly board on the top of it.
And wait, what does it decorate then?
These S curves, they are all little.
But they're
blocks,
they're performative or they're decorative?
Decorative.
But then you're hiding them. So how are they decorative?
No, we think it's it's actually board like the glass. We can see the light can go through it, so we can see it here like right now.
Ah, okay, I see. So I guess that would be really I guess interesting to see how that would turn out in a visually, right? I can't really I don't still understand what you mean exactly, but I guess that might be still interesting. Alternatively, you could also just have two versions of your pavilion, right? Where one you have these S curves and one you have the kind of branching out the structure.
Okay.
That's maybe a bit more straightforward. Last comment about the benches. I think they are super cool. I have a small visual issue. Maybe you can go to your perspectives.
This.
Yeah.
This way.
Yeah. So if you keep that view, I'll just annotate quickly. So no, keep it. This kind of checkerboard pattern takes a lot of the attention.
Yeah.
So
I see that. So
I would definitely try to have this kind of phase out, right, or kind of be more smooth. Because I don't know, like when I looked at it, then the first thing that my eyes were drawn onto were this thing here and this thing here, right? Because it's a very kind of attention-seeking pattern. And really,
maybe
I guess
I need to
really what you want the viewer to take a look at is your amazing roof, right? So just be aware that maybe here you yeah, find a way how to.
I need to change the code.
Yeah.
Yeah.
Okay. Cool project. Looking forward to see it tomorrow.
Actually, I'm quite concerning about the fabrication process. Not just the construction. You first post it on the floor, and then fabricate on top and flip it.
Yes, I want to place the whole roof on the ground and then place all the beams on the on the top of the roof, but it's actually the bottom of this roof. And when hung it up, it will be flipped around and arranged.
Yeah.
So
yeah, how is the construction process when you have two trees inside of your structure, and is it possible to flip?
That's a good idea. That's a good question. Maybe the trees should be planted after this pavilion is made. I didn't thought about that.
Yeah,
or how about you have the beams that are now on the bottom? You have them on the top. Then you can just lift the whole thing up, no?
Yes, that can be easier.
And then you can show the other pattern on the bottom, because that one is flat, right? So you can have.
Yes. Thank you.
Okay.
So we'll jump in. Right?
Mahmoud, I think our turn is next.
Yeah, we're next, but I'm trying to share my
I think
screen.
it's after Georgia and.
Yeah, I'm just trying to share the screen. Okay, can you see my screen or?
Yeah.
Okay, this is the one with the slides, right? Okay, cool. So from yesterday, we were just thinking how to go further with our connection. It was a dovetail connection, and then we realized that it needs a higher precision than normal material deposition sequence. So we were thinking, we had also some goals, strategies for today. So our goals to improve the position tolerance, and also to automate the calibration process a bit, to reduce the human calibration and increase robot-to-robot collaboration. And there was also an issue that every time you move the robots, you need to recalibrate again, I think, and then will be also again human interaction or part of the process. So our strategies was we would try to reduce computer vision usage in the process, and the connections or dovetail connections should be milled with the same placing robot. So just not to move the error from a robot to robot or from a process to the other process. Then we thought about using latching system like we'll see in a minute to sync robots, the coordinates of the robots, and we are proposing to use a kind of spider robot which can help also with latching and coordination. So the first one, the first important thing we think that I mean, when robots are synchronized, we would start with each robot before the assembly to grab to mill its own grab holes, and then pass it down to the other only synchronized robot. So we'll get a wood piece and then just chop them off, and then do the dovetail. And then when we pass it down to unsync robot, then it has to make its own kind of connection for the assembly. That's why we think we could mitigate the error in robot collaboration. So the latching system which we propose, of course, it's not going to be that complicated as the one used in space industry. but we could use a simpler version with very basic sensors. I mean, like the Hall sensor and the positioning system and the servo motors and stepper motor. I guess they have also Hall sensors. Or we can go with the light latching system with infrared sender and receivers. Yeah, and then there's a part when you move between two locations, two work locations. There you would need either to synchronize your localization coordinates with another robot, or maybe you can have a kind of crawling spider which can just save physically the location, and then the robot just need to touch on physically and do the latching and get the proper coordinates. In this case, it has to be always kind of in fixed location, which could help also when, I mean, if the robot needed maintenance and left and then came back to do re-coordination and relocalization easily in a higher position. That's what we thought on robot programming, how to improve the precision of the robot action. I think Misbah also want to say something about spatial configuration and optimization. Misbah?
Yes, I'm just sharing my screen.
Okay. Okay, cool.
Okay, so from yesterday, we optimized the beam design so that it follows a grid. So we thought that the first layer of the roof would have columns in the middle, but then we would kind of free up the layer above it. So we would either have columns right in the center or at the periphery. We did this so that like we have these kind of experiences where you see two levels of the spectacle that will create an interesting experience for the user. And we optimize the surface. And these are the column positions for the first floor in the structural analysis. There were some issues in the center line such that it was reaching the edge of the boundary, so I manually redid a few of them and I found the pieces where there were gaps between the beams. And this is the final result. Like this is the ground layer. I mean the first floor roof canopy, and this is the top floor.
跟你们打声招呼，我刚讲完我的了，现在其他组我不用太多听。
This is what it looks like from the top.
没事，跟你们打声招呼 ，say hi.
That's about it.
Okay. I think maybe in general, it's, for your group, it's relevant to just reiterate quickly what we are actually looking for in the workshop, right?
Mm-hmm.
Maybe we were not really clear enough on that, but really the goal is the exploration of this spatial, structural, and topological potentials, meaning really much more, I guess, what you showed, Misbah, and I'm not really sure if the if it's really relevant, Mahmoud, to discuss hypothetical robotic systems that I guess you wouldn't be able to demonstrate their potentials until tomorrow. Right? I think in terms of the concept, that's all super fun, and I guess for a project with more with a bigger scope, I think that would be great. But I think as a contribution for the discussion tomorrow, I'm really wary if it's bringing anything to the table, because it's maybe not really what we're trying to discuss tomorrow. For Misbah, I'll stop sharing my screen again. I think for your structure, I think that's a very cool thing. I guess also mostly visualization things ahead. In terms of the columns, I have two questions.
Yes.
Do you intentionally put them at the very edge of the slabs in those situations here?
Yeah, I did that because
Here and here?
I mean, I think they could be a little bit offset inside as well. Like they're too much at the edge. But so basically, if we go to the plan drawing, the area so I limited on the.
Sorry, I can't hear you anymore. So.
Okay, I was saying that because of the overlapping of the roof canopy of the first floor and the second floor, the floor area on the first floor is very limited. If I have columns at the center, then that would disrupt the space anymore. So just to optimize the amount of usable space, try to put them at the corners.
Okay, so is it that the columns end up at the very edge because you have this underlying grid?
Yeah, that's also there.
And then the question is, why do you have this grid? If the whole point is that you can now be very free from the grid.
Okay.
I mean, I know that this is in the general discussion of buildings, and in most of the, well, if you work in an office, then this would be like very much a point for discussion. But in our case, right? I mean, you just move that thing in here so that it's here. Right?
Okay.
And this guy, you just move it here.
Okay.
And this guy, you move it here. Right?
Yes. Okay.
And then the arrangement makes way more sense in terms of its spatial conditions, right? With the assumption that an inhabitant of your structure is not gonna experience the grid anyways, right?
Yes.
So the grid doesn't bring any quality to the inhabitant, and based on the computational tools that we employ, we're not anymore bound to this kind of stringent system, right? And I guess what you're showing is exactly the situations that we would want to overcome, right?
Okay.
So actually, maybe for tomorrow you could easily spin a small story around I don't know, that I'm not sure if that's really relevant, but I guess you could easily say, like, okay, we have this grid, then we want to achieve this certain slab blob, right, or splotch, and then we need to deviate from the grid with our columns, and then you show the final concept.
Okay, I'll do that.
And I guess the question would be, are you guys gonna also show a concept for the robotic fabrication based on what we have attend with the simulation tools that we gave you?
Yes, we'll be doing that for tomorrow. I was having issues with the grasshopper file, so I think Mahmoud will be helping me out with the system.
Okay, great.
Yeah, I think we have some tool paths already.
Okay.
And yeah, just we would applying with them to fabricate partial stuff. I mean, I'm not sure if we can do the whole system.
Cool.
Cool. Thanks.
Thank you.
So, group 2 or not, was it?
Yeah, sure.
Good.
Let's
I'll
do it.
quickly share my screen. George, do you want to kick off? Meanwhile, I open the videos.
Should we do it on your screen or should I share?
I think it's shared, so if you press next, then
Yeah, go ahead. Oh, sorry, I see you, not this. Okay, so
do you want the PowerPoint or the?
No, this one's fine.
Good.
So this is just a recap where we left it off. I think between the we're looking at this modular system with irregular column placing, and in terms of the two ways in which this could expand horizontally or vertically, we're more interested in the way it could expand into a multi-story typology. So how the columns in irregular placement could interact and influence the beam structures from one level to another. If you go to next, we were looking at the ways in which this could be fabricated, and our first, if you see on the bottom two images, the first way we thought of how it could be built is that you'd build the first level, and because of the undulating structure, you would potentially need to build a temporary platform, which might not be as efficient. In terms of the robot placement, it would have to be done incrementally. So within the robotic arms, maybe 3-meter radiuses. So done as if it were a cone, you would only build within the reach. If you go to the next slide, yeah. We tried to optimize the construction process. So you would, from the top left, we would first construct from, first build the slab, and then the robotic arm would build above and not below. The second step on the top right is that you place the missing columns and continue the columns on the first level. The third element would be to place the slab within the second level, but at a lower, place it on top of the first level slab. By doing that, your robotic arm can still be on ground level, and you could still assemble. If you see that the little diagram on the right, you could still assemble those portions of the slab above. So then the next step would be to raise that slab, get the robotic arm and vehicle on the second level, and finish the remaining half. So we thought that would help avoid having much more temporary construction and a scaffolding and whatnot. So you could keep on building level by level. Maybe you can share the animation, and then we can go into some structural solutions. So the animation, as we said, we would build it on top of the slab and not on the bottom. And this works for us in terms of how it would be stepped. We would do it within the reaches. And then Chris is gonna expand on some options we've been discussing on the tension and compression within the beams.
Yes, great story, George. While George was continuing on this aspect, I dove a bit further deeper into the structural behavior and how the system of beams will work. It started with the optimization, where since the optimization was sufficiently fine, our grid system does go through the columns. We had manually adjusted also the grid for it, that all the columns are definitely included in the pattern, which was then the basis for the generation of the elements, where this was the first start with just using the standard script, which had been provided. But as we already yesterday had explained a bit, that especially for the compression side, it would make more sense to have the elements directly be stuck against each other. And so we were really wondering if we could use could start up with that pattern. So we created a new pattern between the points where all the elements are connected in the corners. That means that they have to be cut at specific angles, but that just means another tool on the robot, where you get a kind of pattern like this. And where the next question for us was, how can we inform this pattern with real behavior? The first step was making use of density as an approximation for how big the bending moments in certain beams are. This is the density plot you normally get. We added some additional pictures to get more feeling which sections will get what density, and more red means more density, so a larger section. The other part where this is basically where you see the complete full beam system being assembled, being adjusted as well in height as in width for the larger densities. And those two systems compare basically side by side, one with the individual slats, one with the continuous beams. And we were really wondering, how can we combine those systems and let it further be informed by the moment behavior, what's happening in those slabs. So can we, for example, here in the middle, use for the top part of the beam a different pattern than for the bottom part of the beam? So we start exploring that more, but first recognizing where there is tension and compression in which areas on the top of the beams, which again then was mapped on the pattern of the beams itself, where in this case red means that there is a field moment and there is compression at the top of the beam and tension at the bottom of the beam. We then let this system inform our design, so that we basically for the columns get one pattern on top and the other pattern at the bottom, or vice versa, in the middle of the span, which gave us a more interesting pattern, also informed by how the system works. And then the next step, what we were thinking, we will connect it to a timber floor. So basically the floor itself can also provide one of the flanges of a kind of a beam. So which made us move further towards a kind of sandwich structure, where the bottom of the beam is again a kind of solid, and the top of the beam is also solid because it is the slab itself. And intermediate structure can be way more fine or separate elements for which we use the original script, which in total will give us a kind of beam structure built up of a top flange and a bottom flange with more capacity, and an intermediate structure which is more loosely spaced. And that's basically where we ended up right now. We are kind of discussing between what direction to go on. This would make structurally more sense. The other one is maybe aesthetically more pleasing. So we're really wondering what you think about it.
Mm-hmm.
That's it from our side.
Thanks.
I think that's a really cool push, I would say, right? Where you take a building system and then very kind of you almost surgically try to implement additional considerations, right? Which is super cool to see, I think. I think the aesthetics of the system could actually be very interesting also with this kind of solid light combination, right? I think what might be the main reason for it maybe now looking a bit chunky is maybe the way that you generate them. I guess this part here is very successful, right? I think that's like really, I think looking at it, it seems there is like a very clear distribution of the members, right? Where kind of to form a kind of cohesive whole. Whereas then this part here, right? Somehow this becomes a bit more disintegrated, and I wonder why actually, right? I guess maybe it helps if you give us a bit of a insight how you actually modeled those, right? Did you prepare an algorithm and it's the same algorithm, just here it works and here it doesn't, or?
Yeah, I think the difference between the two elements is the beam height itself, coming from the density. Where in the red circle there are only 2 layers, and a kind of 2 layers over the complete end from left to right. And for the other one, it requires a 3rd layer because of the larger density, larger bending moment. So it adds another layer, and that makes it kind of stuck. Because I think you could imagine if this middle element would be a bit more towards the middle, then it would become more continuous. I think also whenever the elements are now generated in between, are not overlapping between the 2 segments. And I think when you put a kind of random extension on it, whenever they can continue, you get a way more smoother pattern and variation over it. But that's a challenge for a few days, I think.
So you take one line segment and you generate the pattern based on the information of the structural analysis, and then the second segment you do the same thing. Okay.
Yes.
So I guess that kind of approach is gonna be very challenging for avoiding overlaps and kind of collisions, right? But maybe that's really not the point of your exploration, right? So I would actually be much more interested in having a bit more insight in how this kind of would look like, right? Whereas a check that that all of the beams don't collide, right? So I guess
in terms of generation, what we did is that we generated 2 complete different structures, one with slats and one with normal beams, and then we start to change to change them out. As in, for some aspects and some layers, we took parts of this structure. For the other aspects, we took part of this structure, and each individual structure is completely collision free. Whenever you start to mix and match them, there are some issues there to be solved. But basically means that you have to cut the elements a few times.
Yeah, I understand. But I guess what I'm saying is that for your project, I would say it's way more important to understand what kind of visual or what kind of density differentiation you could achieve having your structure be informed by this kind of compression, tension information, right? And for I would say focus on that, and if some of the beams collide somewhere, then whatever, right?
Yeah, that's
for a 7-day project, that's I think totally okay. And it's way more, I think it's way more interesting to have you guys focus to show what is really the core of your contribution or your surgical refinement, right? And I think with that, wait, that's a different Wait, that's a different view.
Yeah, that was a different option. The other one we have seen just was just following the moment lines. This one is basically going for the sandwich alternative.
Okay, I see.
Sandwich option.
So if you go back to what you showed before, I think exactly. So if you guys manage to get this kind of smooth interconnection between the more solid and the more light areas, then I think that would be very much amazing. I think that would be super successful. And if then there is a beam here that collides with the beam here, then I think no one really minds, right? And it's kind of clear that if you would take the same logic and you would spend a couple of more days figuring out how to solve the tectonics as well, then that could be solvable, right? But I think to achieve this, you guys would probably need to go through all your kind of different approaches and through all the situations and see how these kind of steps appear, right? And where these kind of disjoint situations occur and why, right? And what would be strategies of fusing them together, right? I guess what you mentioned with just kind of adding maybe a random extension to some of the beams would already help to kind of phase them
I think so.
a bit better, right? But I think this is really what you would want to communicate tomorrow, that you can achieve this kind of density, natural density distribution, and yeah, I think that's super interesting.
Any feedback on the scheduling aspects?
What, scheduling or what?
Placement.
I think here also there's an interesting new concept arising with putting the plates on the first floor, right, and then writing them the next one. I think that's pretty cool. Maybe the visualizations are not the most clear in terms of communicating that, but I think it's also fine. I think the concept of your arrangement is pretty straightforward, pretty clear, and also pretty successful in my mind. I guess you could spin a lot of different stories and refinements on it, but given the amount of time for tomorrow, I think you have your condition, right? Where you kind of have your reason for needing to achieve a multi-directional system, and then I think I would put a lot of emphasis on the methods you're employing to achieve this kind of density distributions within the beams. I think that's very interesting.
Great.
Good. Thank you.
Okay.
Thank you.
Hello, is it our turn, group one?
Yes.
Yes, really good. Hello to all of your participants and your and Shai. I just want a minute to share my screen. Okay. Do you see my screen right now?
Yep.
Okay, following the concepts that I had from the current days for generating polygons that they can combine with each other and having just some
Wait, just a quick questions. Are you still working together with Jennifer?
Yes, well, actually, last night we will talk about it surely after this presentation. We spent a lot of time on Jennifer's model for simulating that. That I have simulated and get some analysis from Topos. But really, I'm not sure that it is working. And I think it is better that about the Jennifer's work first. Jennifer's speak, and after that I will talk about it.
So I mean, just to be clear, tomorrow the idea would be that you guys present one project.
No. We had that project. We have worked on that, but we developed my idea and my concept that I have just just combined it with one of my projects and concepts that I will tell and explain about it in.
Okay, maybe just go on and then we discuss.
Okay. As I said, following the I'm sorry, following the concepts that I had for generating a polygon and get it just smooth and have curvilinear angles from just one element that we define as a point, two as a line, and after in 3 points as a triangular, two just octagonal. I think the polygon that has 8 vertices. So we continued and we decided to define one cell or one circle as a place for living, that it has a radius about 2 meters, and we can say that it has a diameter about 4 meters. And we have some possibilities of combining the cells with each other, or splitting or dividing one circle for having different functions as a residential cell, as we have in here. I want to say just the different variations of every element that we have for combining them as a cellular automata that we will see in future slides. Besides that, we can divide the cell into just some parts. We can combine the cells with each other too, for having more and more wider spaces for every function that it is contributed to that. And just they can combine in floors with each other in a just same floor, or they can combine with each other in different levels and floors, as we see in and as we see, it has just development potential for developing and promote it in just a surface, with combining them with themselves or with other polygons in just in the same level or in different floors. Actually, about 1 year ago, we had done with 2 of my friends that one of them is an auditing member here in this workshop, Daniel Karamat, that I will say when we I will explain about the plugin and component that we have scripted with each other in Python. And we have an idea that we can combine and generate a cellular automata grid for just combining the cells and the cylinders with each other, uh, for having a logical combination of cells for a grid to be a place for living it. And as we see, we can have it in generating facets, or I'm sorry, for just some modular concepts that we have in architecture. We can have different rules for combining the cells that they are in the neighborhood of each other, that we can define as an functional element or architectural element. For example, I say that um, the kitchen must be in the neighborhood of dining room, or the water closet or WC or toilet would be in the neighborhood of bedrooms. So we can combine it in a way that we can manage them in just different ways. And as we see, we have a concept that this is a mathematician. I'm sorry, I didn't know what happened, and that's the problem. And here, this is mathematician John Conway's as a hypothesis as a game of life. We combine them and define some rules for generate a grid of cells for architecture. And we, I'm so sorry. And we optimized it with genetic algorithm for having a logical and optimized combination of cells beside each other. And we have the chart of genetic algorithm here. Actually, this component has been written with Daniel Karamat and Mashid Moqaddasi in Cornell University. And we used this plugin and component for generating a facade in a building with defining the grids in just plan and the facade in vertical and horizontal grids. And with defining some logical rules that, for example, the terraces or balconies would be in the final rows of grid, and they cannot be in the neighborhood of the core or the, as we see here, we define as well. And we can see the rules that we used for coding and scripting in Python. And these are the rules that we used for the permutation in cellular automata, and the logical possible combinations that would be for combining the cells with each other. As we see here, and we will define for the Kelver and cylinders, we will have just structural and architectural elements as slabs, solid cells, or I am sorry. And as you see here, we can see some combinations that wouldn't be logical here. So these permutations would be deleted and eliminated in the process of coding. And for example, one of the examples that we produced with this code is just we have I have showed here. We have registered, but has not publishing it yet. So I deleted some processes of getting the final element here. Okay, here we have from one cell to 8 cells in these combinations and polygons we have, and they can combine with each other with other elements that we can just calculate the permutations in combining in floors and different levels, or combining them in just one floor with each other. And as you see, for example, we had an example here that we defined, and we see just the results as we optimized for our slabs here, that it is a plan grid code in the below image, and the upper one is the section that we see in facade, the levels that we can generate. And if we get them more precise and more closer to our work, we can have grids that in every node we have defined the cell for combining them, and also the axes of the just these grids that we can generate just cellular automats with them. The grids can sleep and flip on each other for combining and generating some more innovative combinations. These are some rules that we can define for our work, that the uh, elements that we can define for combining is from one node that we define it as one cell to just octagon, and for having a surface just cover, we can use as you know hexagon without any element between them, or we can use octagon, as I'm sorry if I am saying wrong, because uh, the names are really hard. And with combination them, we can have a potential of some public places with each other in combinations, the polygons that have 8 vertices. We can define 3 elements that it is empty of the space, and in upper levels we can define it as a void. We can have it solid, that we can combine them and define them as a cell or home for living as a unit. And we can have traces that they don't have walls around them, but surely they have a slab or a ceiling on the top of them.
Sorry. No, it's okay. Go on.
Okay.
But how long are you gonna take?
What?
How many more slides do you have?
I'm about 12 slides left.
Okay, so maybe just try to speed it up a bit.
Okay. And another alternative would be the network generation of our work, and at the end we would have the final combinations. And as you see, we can see here the optimized slabs and the combinations of just a triangle, just a square, octagon, and a polygon that it has 5 vertices, and we can define the cells for them here as a residential place. These are the okay. about the methodology for getting the slabs built. As the reach of the robot is about 3 meters, and the levels of the height of our levels is about 3 meters, we can have a bottom-up construction that we can build the upper levels with robots in first level, and we can get them up and have the piles or columns on the lower floors. And we should place the higher columns at first, and after that we can place the columns that they are lower for defining the public places. And as we see that the reach of the robot is about 3 meters, we can just locate it in different locations, and as we defined um, the mm, just span between two columns are more than 3 meters. So I think we may not have a problem for locating the robot in under the slabs for constructing them. And after this, we can get them up and have the middle floors and get them up to their places, and have finally the public places that we defined here. And our presentation has finished. And I'm sorry that I should say that okay, dear Jennifer, would you just want to speak about the work, or I show here and speak about it you yourself, or me? Dear Jennifer, are you here?
Yes. Can you hear me?
Yeah.
Yes.
Can you share your screen, Jennifer?
Yep. Yep. I'll share.
Okay, I will stop.
Okay. So what happened yesterday was we took in your suggestion of having a path-based planning, or a path-based roof system for us. So we created a path curve, and we just did the scripting algorithm in a way that the path would define the user space. So whatever be the path, the roofing will correspond according to that, and automatically the algorithm will provide the slabs for it. So once we finished this, we took it into the simulation script and tried to do the simulation. And every time I did a simulation, I had this problem of getting an invalid mesh. So I will show you how the mesh looks like. We had the problem of getting an invalid mesh that looked something like this. And when I looked into what the issue could be, I found out that it is because the intersection was not being accepted. That is, although the slab and the supports are clearly intersecting when we see in the viewport, in the model component, it doesn't show that way. If I hide everything else, if I hide everything else, there is only the blue arrows. So even though it intersects, I'm not able to get that in the script. So we were not able to proceed with this further, and we got stuck in this step itself. So we thought that it would be a little like we won't be able to complete it for a project tomorrow. So instead, we decided to continue with the route that my teammate Ali Reza was taking. But I would still like to explore this even after the workshop. So I would want to know why the issue is happening. Although the intersections are pretty clear, the component is not accepting it, and how can it, for my general idea, like how can it be solved or sorted?
Did you try to have the slab horizontal?
Oh, these things for getting the slabs angular. So I didn't insist, and I just tried to help having the analysis from angulars. And we had a hypothesis that we can get analysis from just the flat slabs, horizontal slabs, and after get the analysis, we can change them, we can rotate them and have an angular slab.
Yeah, did you try that?
No, because we felt that that wouldn't be an actual result. Like when it's angular, maybe the strain and the stress will act in a different manner. So we thought that was not really the correct way of doing. So we just ended up going for the other.
I think it would be not ideal, but definitely worthwhile to check that.
But we other
because the slabs are only very slightly angled. So I guess forces would still be somewhat similar. And I mean, we're not in the course of really engineering a project, right? So there is no strings attached in the network in terms of the responsibility of you or us as the architect. It's really mostly more about the exploration and the simulation of this kind of specificities. So in that regards, I think your proposal of how you could kind of generate this kind of very interesting kind of roof pattern, right? I think is pretty cool. I wonder if there is if there is plates with only, like, if all plates have 2 columns, or if there is also plates with 3 columns. Because naturally, I would say it would be more interesting if most of them have 3 columns, right?
Okay.
I think there is a lot of this kind of cobblestones where they have like one pointy side, right? And then a more flat side, where the flat side, I guess, would have 2 columns. And then if you're worried in how to finish this kind of project, then I would I guess you wouldn't need to analyze all of the things, all of the plates, right? You could take it as an example, have it run through the simulation, have it run through the generation of the beams, right? And then yeah, I guess explain more about the spatial concept, about this situation where you have the plates being supported in different regions, right? And the expressive nature of such a project, right? And yeah, I think that would be definitely already quite good. So how would the fabrication work in this kind of scenario? You would just fabricate them on the floor and then pull them up?
Yep. I think that would be a better solution, fabricating on the floor and putting on top, since it's like a linear set of slabs, so you could just go in the same direction of the
Yeah.
of the curve and go about it.
Yeah.
Since the slab is also not flat, I don't think it would be ideal to have the slab and then have the robot do it with the roof.
So I think on a kind of teamwork level, I think we discussed last time that that for the overall group, so for all the participants and the presentations tomorrow, strategically it would be more interesting to go along with this kind of proposal, right? Because there is a very similar structure already being investigated by another group with this kind of ring, right? So I would really ask you guys to take that seriously. I mean, I thought that was clear already when we talked about it the last time. I can only stress it again. I think it would be highly beneficial for the clarity of your project, right? If you pull together your forces and investigate this a bit better. And I mean, to be honest, thanks Alireza for super in-depth presentation, right? I think touching upon a lot of different topics, but I really missed the point of where those topics become relevant for the investigations that you do within your group and within the workshop here. So I guess maybe those methods are really better applied in maybe another scenario where in this specific context maybe they're just not the right way.
Okay, thank you. But just the concept for getting the generating forms was that from the first step of deciding for having a building decided to be built to the final step, we can have automated process that all the processes as the first step we call design to the last as construction would be will be automated. And I just try to offer a logical way for combining these cells and metaboles for and calculating how much combinations we can have for a specified grid ever in just planner or as we can say a special grid.
I still don't really understand how this combines somehow. I guess also maybe our approach is a bit trying to find maybe a bit on the verge of kind of navigating through the jungle of computation where some routes take you towards like automating everything, right? And I think from maybe that's also a very personal note, but I think as architects we still have the main responsibility of crafting space and structures and the environment that we inhabit, right? Which its main quality is that that it's a communicative effort with all the stakeholders, right? With inhabitants, with the client, the developer, with the local craft, and so forth. So I think in that sense, it's really I would see it really critical to propose the fully automated generation of structures. Right? I think we all agree that there is certain potentials in the computational power, right? And we definitely should leverage tools. And also they fundamentally change how we can create space. But I think the notion that there is a certain cultural and socio-political understanding of our built environment, right, that cannot be just overridden by an algorithm, or it can be overridden, right? But the results are not going to be better, because the only way that that algorithm would lead to more successful or more performative architecture is if it can read the minds of the context of the people that it tries to solve an issue for, right? And I think in those regards, we as the designers are really much more suited still. Really propose new experiences and new ways of creating space, right? And with that, I don't know, like that was maybe a bit of an excursion, but I think coming back to your project, I would really advise you to go forward with a very simple idea of what your contribution is to the conversation tomorrow, right? I think it's gonna make a very, very bad impression to both the guests, the audience, and whoever to have have a presentation where it's apparent that there is like a very big gap between like different developments. So I think really just maybe just we can also just schedule another quick session later on where we try to solve this kind of problem with the inclined slab, right? But I think that should not be the problem stopping you from further developing that approach, which I think is quite interesting.
Okay, thank you. Just for final speech, I want to show you the results. We just had some problems as I checked the code, as dear friend Jennifer said, that we don't have an intersection between columns and slabs. And as I guessed that the C# component that has been defined in an intersection of surfaces in a horizontal way. And we should define the normal for that. And as I really don't know, and I'm not influent in C# scripting, and dear Jennifer insisting on just having Angular slabs, I just try to get some analysis that the topos are really weird, that we have really just low eliminated cells from the parameters. So you propose that for tomorrow we just working on the horizontal slabs, or what?
Yeah, I think what I would propose you guys to do is to make the things horizontal, see if the simulation works, right? See if you can generate the pattern with that. I guess then either you bring it back to the inclined position, right? And you can just be very honest that this was the way that you did it. Right?
We thought about it last night, but Finally, we thought and we concluded that it is a deceiving conclusion that we get analysis from a horizontal slab and get it angular and present it as a optimized slab.
Well, that's a matter of how you communicate it. Right? I think there's no harm in saying that. Okay, we tried to. If you say we tried to analyze it in the inclined way, it didn't work. So we just took the values from the horizontal way, applied it to the inclined position, right? And continued the testing of the beam arrangement and the assembly, the robotic assembly with this hypothetical network. Then it's like, if you're just straightforward with it, then there's nothing about it that is conceiving. I can only stress again, like, we're not building the structure, right? So no one needs to take responsibility for it being the actual numbers, right? It's way more of a conceptual question. Okay, we get the results from the optimization, right? Can we now form it into a tectonic system, right? And can we then have a proposal how it's fabricated, right? And then I think it's going to be very clear to the audience that if you solve the structural optimization of the inclined slab, right, which maybe is just right now out of the scope of what you can do, or what you have the time to do, or actually what we can do, right? That's totally okay. No problem.
Okay, thank you very much, Shai and Rico.
Thank you.
Okay. Maybe just give us a quick update as soon as you got the topology optimization run on one of those guys, right? And I just remember, maybe it's possible to have 3 columns on most of the things.
Okay, and we both are not having WeChat, so will it be okay to mail you the update?
Yeah, sure. I mean, the main conversation still is running over mail, so that's totally okay. Cool. So I think we skipped one group. Was it group 9? Bahua, do you still remember?
Yijian and Zhang.
Are you guys ready?
Are you here actually?
Zhang, we see that your mic is on, but I can't hear you.
Hello, teacher.
Yeah.
I'm here.
Hello.
I'm here. My work doesn't finish. Tomorrow, our team will show our design.
Okay. Maybe for you also, just maybe you can just send us the status quo of your project per mail, if that's better.
Or if you want, you can show what you get for now. Hello.
Frank? His connection is very bad. Okay, then maybe we just get in contact with him. Ah, hey. Hello.
Hello. Hello, teacher.
Hello. I think the connection is very low, unfortunately.
翟老师你好。翟老师，不好意思，我这边可能这个视频连的比较慢，然后我那个作业已经传到网上邮箱的一部分了。那个我和我这个组员，我俩英语都稍微差一些，真的太抱歉了。作业有一部分已经传上了，然后我们整理一下，明天我们做一个那个发表吧。
那我能打开在这儿看一下吗？给雅各布。
可以在我们现在是我就用汉语跟您说了，不好意思，我是用 Sketch 做了一个我们那个大概的设想，现在已经做出一个模型了，然后我们希望用那个犀牛和 Grasshopper 把这个 Sketch 做的模型实现，已经上传了。
哎，我没看到哎。
哎，你
第几天你们上传的是？
哎呀，是上第二天吧？还有今天的也有。你等等我这个电脑里可能还有，我找一下。
我只看到了第二天的机器人模拟部分。
今天的也有一部分，今天的文件夹。
So they said their our English is too good. They can express them very well.
Yeah.
I'm trying. They said they upload their files in the Google Drive folder, and I'm trying to find that. 哎，我没找到哎。
曹老师，我可以发您微信吗？
可以。
我给您马上发您微信，稍等一下啊。陈老师发过去了。有一个那个
这不是那个案例吗？哪个是？ Maybe we skip this part. I didn't find the.
Yeah, maybe we just or maybe you can get in contact with them.
Yeah.
I think they don't need to be very literate in English. Fine if they just show the work if they want, but also they don't need to present red. I mean, it's more like an offer. Present. There is no. I think if they don't feel comfortable presenting, then they also really don't need to.
I will ask them. Okay, so
Yeah, I think we went through all the teams now, no?
Yes.
With that, I think the tutoring part of our workshop is somehow getting to its end. I think I can only stress again, whatever is coming up in the next hours or until tomorrow, just reach out to us and we'll do our best to be very apparent and helping you out. And I personally am looking super much forward to the presentations tomorrow. I think we're gonna have very nice conversations with you, with our guests, with Philip Juan, and please stick with the 5 minutes presentation limit. Otherwise, as we have a fixed time of 2 hours, otherwise this means that the later groups are gonna have basically no more time left to present. So I think we're gonna need to be somehow strict about that. And with that, I guess just don't forget to find appropriate ways of presenting your concept with maybe 2 points that I want to stress again, that kind of overarchingly are super important for all of the projects. Where first, you want to really communicate how the spatial boundary definition, right? Very first part of your research exploration is contributing to the construction possibilities in a way that it offers new ways of organizing space, right? Or is offering new ways of exploring what is a timber slab, right? So I think that would be really a part that is ideally communicated with your diagrammatic concept, right? But also probably with some visuals, right? Some perspectives. I think no one is expecting high glossy renderings, right? I think that would be out of the scope, but just make sure you have some clean perspectives where the spatial experience of your structure is kind of explained and visible. And then I guess the second point would be that as we are going through all of your groups, as we were going through them today, and as we're gonna go through them tomorrow, it's highly interesting to see like your specific focus point, right? Where you really are pushing the boundaries, right? So I guess we gave you a certain framework, right? And then we can see in each project there is like a certain push, right, or a certain focus. And I think, I tried to highlight that now in the feedback that we were giving, where we feel is the kind of explaining where we have the feeling an area is contributing most to the conversation tomorrow. And I think it would be highly valuable if each project can further develop these parts for then having a very interesting presentation tomorrow as a whole group, right? So I think some of the projects are a bit similar, and therefore it's even more important for each of you to discuss like what your project has in specific that is different from what we were proposing, what maybe other teams are proposing. And yeah, I'm very much looking forward. Thanks so much for sticking with us, and I hope we were able to offer you an interesting workshop. And with that, I guess we're looking very much forward to see what you guys are able to kind of pull off in this last push until tomorrow for the final presentations with Sam Wilkinson and Pablo Zamorano and Dominga Garuffi from Foster's, Werner Sobeck, and Hedderwick. And actually, I can also bring that up quickly on the screen. So that also maybe our auditing members can see. So tomorrow's final presentations, we're having invited guests from practice and academia, and we're super delighted to have, I think, quite an impressive set of really experts, but also leaders in the computational design field be present tomorrow. Sam Wilkinson from the specialist modeling group in Foster's and Partners, highly involved in the whole smart geometry group and organization. Dominga Garuffi as a very young and coming figure, currently working at Werner Sobeck. And Pablo Zamorano from Hedderwick. I think all of us are aware of some of the later work from Hedderwick with the vessel in New York. Really, really exciting projects where computational design was applied on a very large scale. And then from academia, Dylan, Martin, and Xiang Wang. Dylan from ICT was highly involved in the Urbach Tower that Simon also was presenting today. Martin was involved in the Boogerwood shell. Both of them have now quite an elaborate set of computational design portfolio, and Xiang Wang being one of the leading researchers in Tonji. Yeah, with that, I think we'll give it away. Thanks all for sticking with us, and again, just get in contact with us in case there is a last minute problem popping up with one of the scripts, or maybe even if there is a question that is regarding the concept or regarding question of how to present tomorrow, then please feel free to just contact us at any time. First thing that can happen is that we don't respond because either we're sleeping or whatever. Yeah, but we'll try to do our best to be reachable throughout the next 24 hours. Okay, did I forget anything? Well?
Just Jacob.
Yeah.
I just wanted to jump in. I really appreciate what you've done, you and Hua, during the last days, and I really appreciate how you did communicate all the information and all the technology which you're currently using. But also, what was most important, sharing the current challenges in like real life scenarios, how it goes actually, which opens new opportunities for us to think and challenge the boundaries of what's existing in the state of art technology. Yeah, I just can't stress enough on how much I do appreciate what you've done.
Thanks, Mahmoud.
Thank you.
I think that's good to hear, because obviously it also takes it's very painful to to stick with the to always consider let's say more practical constraints into the equation. I think the field of computational design can be very creative, and there is a lot of things that one can explore. And then sometimes trying to also push into practice can feel somehow constraining. So I think it's great to hear that this is. Thanks. Okay, then I guess Hua, last words until we see each other tomorrow.
What?
You want to have any last words?
I mean, there is gonna be a additional troubleshooting session for the group 5 after the meeting, so do not close the meeting after that.
Yeah, maybe. I mean, we can also just leave the meeting room open. Yes, I'll stop the live stream, and we can discuss. Whoever is interested can just stay within the meeting, and yeah. Okay, cool. Then with that, I need to go and grab some lunch very urgently. And let's stay in contact. I'll stay in the meeting room though, and if any question pops up, just text. Okay, thank you. Whoever is leaving now, see you tomorrow, and we're super excited to see what you guys are gonna present tomorrow. Okay.